So first I will give you a quick demonstration on how to create a Docker file and how to build an image. After building the image, how to tag it and how to push it to the repository, that is Docker Hub. So I'll show you my login account on Docker Hub. The URL is hub.docker.com and I'm going to sign in and I'll show you. This is my user ID and the password, and you will see that I have only one repository here. So I'll not create any repository. I will be creating the repository directly by pushing image from my local system. So for this purpose, I'm creating a directory mkdir, let's say OCI, cd OCI, and here I'm creating a file, Dockerfile. This is the name. Remember, it is case sensitive. D is uppercase, Dockerfile, and here you put the instructions. I'm using the instruction, simple instruction. One is from busybox. This is the instruction which tells from what is your base image on the top of which you are going to create this image. So my image will be based on the busybox image. And this is a CMD. We'll learn in this session, that is next session, about these instructions, what all instructions we can have to build the image. In this particular Docker file, I'm giving only two instructions. One is the from and second is CMD. And I'm using this instruction echo hello world. This is my first Docker image, the Skillpedia. So I'm going to build this image, save this and quit this file. And now you can use the instruction docker build, and tag name you should specify the tag name -t, the account name on Docker Hub, which is this account slash repository name or the image name OCI, and colon tag name, tag of the image. For example, the image name I specify as v1. This is the name how you specify the name of the account on Docker Hub. This is my account name. This is going to my image name or the repository name where all the layers of the image will be stored, and the version of the tag will be v1. From where is the Docker file? After space I need to put the dot. Dot represent the current directory. I'm working in OCI directory and my Docker file is in the current directory only. So the image is built successfully and it is tagged successfully, because if you remember, that file was available already in my case. Which file? The busybox. You remember the image was available. If you check Docker images, you will see the busybox image which I downloaded and the one which I have created, that will also be available, Sang 170 OCI. This is the image which I just created and of the same size because it is based on the busybox image. I can push this image now, Docker push, and you simply use Docker push, push. In fact, before that, before I use Docker push, I need to log in also. So Docker login -u and my username. So I type my password to login. If I get message login succeeded, then I will be able to push the image. So login succeeded. So I'm logged into my Docker Hub and I can push the image. This image, Docker push, and the image name. And don't forget to remove the dot because the dot was for building the image. So Docker push this image with the tag name, it will push the image. And now I'll go to my Docker Hub and verify that image is successfully pushed or not. Let me see first after the image is pushed. Yes, done. Now I can check here. I refresh it and I will see my OCI image available here. You see the image is available, Sang 170 OCI, and if I click on this, I can see the tags also, the tag which I just created, v1 tag, right? So all these images will be available, and in fact to pull this image the command is also given to you here. How do you pull this image? So this is private image, you will not be able to pull it. if I pull this image from my system on my system right now, I can use this command docker pull. But because the image is locally available, it may say that it's already available. Image is up to date and it is available. So pull, whether it was working or not, I can check with the last pull option here. Yes, it was pulled, and you can see a few seconds ago it was pulled. So that's the concept. So that's how we create images, and we push the images to Docker Hub, and then we pull them from Docker Hub. What is important to learn here is the instructions we specify in the Docker file. And this session is about these instructions and creating images and pushing them to Docker Hub and managing them into the repository. Let's start. Session 3, managing Docker images. Agenda of the session is downloading Docker images, modifying images, uploading images to Docker registry, and running multiple containers. Well, you may not be learning this multiple containers in this session, but yes, Docker instructions for sure we are going to learn in this session. So the basics of Docker system, now you have seen during the demonstration. You create a Docker file in a directory of your choice. Let's say it is a Docker file for image A, which have the other source code as well. Call it as a image file system, where you are going to have, and that image file system you have created in your local directory. So I'll call it as a local file system, based on which I want to create image file system, IFS. Let's call it that way, image file system. So I need the Docker file in this directory where my local file system is, and rest of the source also, and the everything I want to put into my image, into image file system after the build process is over. So the Docker file is created in the image local file system. You use the instruction docker build that will result into building the image A. Then you push the image to Docker container registry or image registry, which you can search from other machines using search command, or you can pull the image using docker pull, or you can run the container based on that image using docker run. So we must have Docker daemon process running on the other machine, where you can have multiple containers running based on the image. And this is a host machine where you are working, where you have your source code, and you are building the image on this machine. That is where your source code is and where Docker file is. So you build the image, you push the image to the registry. From other machines, you push, I mean you pull, you search, or you run the images, or you run the container based on the images. This is the whole cycle. So what is the Docker file? The important thing which is part of this now, important part here is the Docker file. Docker file is a text document that contains all the commands a user could call on the command line to assemble an image. It includes how to run commands, add files or directories, create environment variables, what process to run when you will launch container based on this image. So result from building Docker file is Docker image. You have seen the demo. So what all instructions we have in this Docker file? That is very important point. Please try to visualize these two parts: image file system, IFS, and local file system where you are working. Because you will be working in the local file system directory, everything should be in this directory or relative to this directory. And when the Docker build will run, it will put the content or transfer the content based on this local directory. It will build the image file system or the image. That's the important point. So we have to visualize two parts here carefully. First instruction, if you notice, was from instruction. From is the first item in the Docker file. It specifies a parent image that your image will start from. In my case, if you see, it was from BusyBox. In this case, you see from Ubuntu 18.04. For instance, to use a image called TSP demo from with the tag v1 from Sangwan account, you probably would use from Sangwan TSP demo v1. You can also use from scratch. From scratch is a special case where you want to specify that no, I don't want to use any base image. My image does not depend on any other image. My image is from scratch. To indicate that your image should not have a parent image, it is a pseudo image actually that indicate that you want to start without a parent image. Under what circumstances you will use it? What are the scenarios where you may use this scratch? Very simple example is you have a simple binary executable created from C language source file. Think of a simple C program which is compiled and converted into binary executable. And you want that binary executable to run inside a container. You want to containerize that binary. That can be done without any base image because that is self-sufficient independent binary that will run without any other requirement. So therefore, in that situation, you may use from scratch. Label instruction. Label provides the ability to add key value metadata. Metadata means data about your image. It has no other significance apart from the metadata within your image instruction, within your image file system. So label instruction can be used as many times as you want. So label key equal to value, or label key equal to value 1 space key 2 equal to value 2 space key 2 equal to key 3 equal to value 3, and so on and so forth. So multiple key value pair can be specified to add metadata to your image file system. Like for example, author, website, URL, copyright. You can add those kind of metadata to your image to specify details about your image, which has no other significance apart from the information about the image itself. Then the add instruction. Add instruction is the real example where I was talking about we have to visualize two things. So you want to add something from your local file system to image file system. So to transfer data from local file system to image file system after the build is over, you use this instruction add. Add is a way to copy file from the local file system or a remote URL or a local compressed archive file. So good thing is that it supports local file, it supports remote URL, it supports compressed file also to a location within the image file system, which I was referring, image file system. I'm talking about this now. This is image file system. So you specify add source, then space destination. The source can be local file or remote URL or a compressed file. The same job can be done with copy command also. Copy command is similar to add. Copy, source, and destination. Source is your local file system, destination is your image file system. Then what is the difference? There is a difference between the two. Copy command can also take this argument from, which add command does not support. Hyphen hyphen from. This is a very good use case to build image from multiple images. That's called multi-stage build. We use from instruction. So from argument. We use multi-stage builds. The copy instruction look incredibly similar to the add instruction at the first glance, and it overlap in purpose. The difference is that copy only works with local file system, means it cannot be used to remote files. Also, it cannot be used with compressed files because it provides no support for automatic archive extraction. So there's a difference now. Copy and add. Copy cannot work with remote URL. Copy does not support extracting the archive files. You cannot use copy to copy compressed files. Environment and expose instructions. Environment is used to set the environment variables. What is the use case of environment variable? Think of the MySQL or WordPress website. I want to create a WordPress web server where I need to specify the user ID for my WordPress admin user and the password, or MySQL port number, or the user ID or the password. So those values which you want to pass at runtime to the container. How these values will be used inside the container, you need to have some placeholders inside the image file system. So these placeholders for the image file system are called environment variables. So you specify these environment variables in the image so that the user can pass the value of these environment variables, and then you can use these environment variables within the image file system to do the job. So as an example, environment, and there are two format here, two syntax. Both syntax are valid. One is without JSON format and second is with JSON format. So key space value, that is also valid. Key equal to value, that's also valid. Then expose instruction is to allow communication of your container with your outside world or the host machine, because you need to tell that on which port my container is listening. So the port exposed or port on which the container will be listening on to talk to the outside world, that can be done using expose instruction. So expose instruction communicate which port the container services are listening on, and you have all the possibilities like export, expose port, or port slash protocol like TCP protocol or UDP protocol. Then we have the run instruction. Run will execute the statements given to it within the image file system environment during the build process. In fact, think of a scenario where you have the source in Python and you want to build binary out of this Python by using build process or build instructions inside your image file system, so that you can remove that source code and intermediate files and keep only the binary executable or target. All right. So that can be done using run instruction. So this run will run inside the image file system. This is the primary mechanism of making changes to the build to build your images, of course. It can run any command available within the image file system context. Run followed by command. This is the first syntax. Second syntax is the JSON syntax, where you specify like list item, list executable separated by comma, and in that you specify the arguments to this command. So this can also be used. Both syntax are correct for run instruction to be executed inside the image file system. User instruction. User controls what user and optionally group. The commands are executed as in the an image file system, meaning that if you are logged in as root user, probably all your instructions will be executed as a root user only. But no, sometimes you want that image should be executed as somebody else, not as root user. All right. So that can help you. That can be done using user instruction. User followed by group also. This can affect both the build and runtime process, as every subsequent command that will run in the container environment like run or cmd or entry point will be executed by the provided user. So you specify user, user ID, and group ID separated by colon, or user name Both can be supplied, like username followed by group name or user ID followed by group ID separated by colon. That can be used. That is user instruction. Then volume instruction. As I said, we can mount external volumes, bind mounts or volumes. So where these volumes or external storage will be available inside the image file system. You need to create some placeholders. Technically, we call them as mount points. These mount points need to be declared in the image file system. So that can be done using volume instruction. So volume is responsible for creating mount points within the container's image file system for mounting external volumes from the host or other locations. Syntax of volume is quite simple, like volume, and this is JSON format. Data volume 1, data volume 2 separated by comma. You can keep as many volumes as you want. And second syntax is also valid without double quote, without comma. You simply specify data volume 1, data volume 2, space, data volume 3, data volume 4, and so on and so forth. So with or without space, with the JSON format or without JSON format, both formats are valid for volume instruction. Then work directory. You know that you, while building the image, you will never be getting inside the image file system. You have to visualize it. So you may have to visualize that, okay, I want to work in that directory and I want to execute my instruction from that directory. Whether the directory exists or not, that is a second question. This is done by work directory instruction. The work directory declares the directory context for instructions like run, cmd, entry point, copy, and add. It specifies the location on the file system where these commands should be executed. Interesting point about this work directory is that even if the file does not exist, I mean the directory does not exist, it will create the entire path for you. So work directory instruction will automatically create the directory and any parent directories required or specified in the path. So you specify work directory and the path. So that path will be created in the image file system if it does not exist, and you will be placed in that directory to subsequently execute the commands after this command onward. CMD and entry point instructions. The CMD provides default execution instruction for when a container is run from the image. This was the instruction I used my image. This was the second instruction I used in my image I created. This is the primary way to specify that what should happen when a user execute Docker run on your image. For example, cmd ls-al var log, then wc-l or cmd, the path to the executable with parameters, or entry point, path to entry point, and cmd parameter 1, parameter 2. All these are possible example or syntax for cmd and entry point. Entry point allows you to configure your container that can be run as an executable by default. What is the meaning? That when you run this container based on this image, it will run the command directly without waiting for you to send something to it. Whatever command. For example, if I say entry point ls-al, so whenever you run docker run on this image, this command will be executed inside the container. So this will simply display all the files in the container file system. That's how it works. Quite simple. So these were the comprehensive list of instructions that can be used to create Dockerfile to build your images. Now the Docker Hub. Docker Hub, that is hub.docker.com, is a cloud registry service for sharing application and automating the workflows. Major features include public and private Docker repositories, official repositories, collaborators, organizations, and groups, automated builds, and webhooks. Build and push an image to Docker Hub. You have seen the demo. We are going to run a busybox container on our system and get a taste of Docker run command. Busybox is a software suite that provides several Unix utilities in a single executable file. So pull the image, Docker pull busybox. It will pull the image. Then create the Docker file, and these were the file which I created from busybox and the command I executed. Echo, this was the same command I created. I created the same Docker file. Whether you use this cat command or you use VI editor, ultimate objective is put these two instructions in Docker file. Remember, D is uppercase in Docker file. Then use this command docker build, tag name, your username. This is your Docker Hub username. Then a registry name on the Docker Hub and the tag name. And the most important, it is separated by space, this dot. This dot represents the current directory where you are working. And this is same command I executed. In my case, the tag name was v1. So any tag name can be specified. To test your Docker image, you can run the command docker run your complete username and the image name or the repository name and the tag name. So docker run sang170 OCI my tag and the same output what you expect, which was given in the cmd instruction in the Docker file. Tag this image and push your image to Docker Hub, Docker login, and I use my account name. Then tag, this is a hello world example, hello world, and then you can tag that hello world image also, your username and OCI and tag name, and push followed by your image name. So this is same demonstration I gave you, that I pushed my image to Docker Hub. And after that, you have seen my image on my OCI account as well. And you could see that this account and the image and the tags which I posted, which I pushed to my Docker Hub account. That's all for this session. Recording of this lecture is available at this link. You should watch the recording to revise this topic. Thank you very much.